Hello, pre-calculus students, and welcome to our continuing lesson on analyzing behaviors of higher order polynomial functions. And we have an example here that allows us to tie all of these concepts together. So the first thing I'm going to do here is we'll read the problem, which says, for each of the following functions, identify the zeros, identify the y-intercept, draw the graphs, give the end behavior. So the first thing I'm going to note here is that these numbers here are the multiplicities, and that's going to tell me that the degree is equal to 2 plus 3 plus 4, which is 7, 9. So this polynomial has a degree of 9. Okay? Now, the leading term, or the leading coefficient, you see here it's going to be x squared times x to the third times x to the fourth. There's going to be some other terms in there if I were to multiply this out, but I know I'm going to have x squared times x to the third times x to the fourth. So I know that the leading coefficient has to be positive. Okay. And then the next thing that I know, which is going to be very helpful for me, is looking at these zeros. Well, this function is already in factored form. You have x plus 3 squared. I can set that equal to 0 and solve for it. Then I have x plus 4 squared, or to the third, equals 0. And then I have x minus 2 to the fourth equals 0. So my zeros are going to be at x equals negative 3, x equals negative 4, and x equals positive 2. Then I also know that the multiplicities of each of these is 2, 3, and 4. So this is going to help me quite a bit in order to sketch my graph. So I'm going to sketch this out right here. I know it's going to touch the x-axis at these important points. At x equals negative 3, at x equals negative 4, and at x equals positive 2. I also know that the y-intercept is going to be f of 0, which is 0 plus 3 squared times 0 plus 4 to the third times 0 minus 2 to the fourth. So multiplying all that out, this gives me 9 times 64 times 16. So that's going to be a pretty big number. So it goes 9,216. Okay, so if you were to graph this on your calculator, you probably want your window to be at least that big. Okay, I know that a lot of people have a hard time struggling with that. Now, one thing I do know is that since this is an odd and this is a positive, it's going to look something like this. Okay. And then I also know this is an even multiplicity, so this is going to kiss, this is going to cross, and this is going to kiss. So this graph, as I draw it, it's going to start down here. It's going to go up to 4, kiss it, turn back around. Now it's got to go back up again, otherwise it can't cross over. Sorry, for negative 4 it's going to cross. So it's going to cross at negative 4. Let's erase this. And then at negative 3 it's going to kiss it. So it's got to come back down, kiss it, come back up. And then it needs to come back down again in order to touch negative 2. And so at some point, it's going to have to pass through this point here. And we don't know if this is the maximum, but we know it's going to pass through that point. It's going to come back down, kiss at positive 2, and then keep on going up. Okay? So the end behavior is the limit of f of x as x approaches infinity is going to be infinity. And the limit of f of x as x approaches negative infinity is going to be negative infinity. So I got the intercepts, I got the x-intercepts. I'm using these zeros and these multiplicity to see what the behavior is going to be, and that gives me a pretty good picture of the graph. Now, in the next example, the next video, we're going to actually graph these examples and compare them, but we know it's going to look pretty similar to this. Not exactly, but it's going to look pretty close to that. Thank you for watching. Have a wonderful day.